Hey everyone, welcome to another tutorial. In this tutorial we're going to just quickly make a really simple three-dimensional character controller just to demonstrate what we'll be able to do. So I've got a little sphere here in the scene. I'm using my mouse look script from my other tutorial. We can hold spacebar to go up, left control to go down, and we can move forward in the direction that we're looking, or backwards, and we can strafe left and right as well, and it's all dependent on where we're looking. Okay, so you can see I've got a new scene open in Unity. The only script I have in my project folder is this mouse look script, which I've made in my other tutorial, which I'll link in the description. Okay, so we need to create a primitive sphere, which we can do by going to the hierarchy window, right-clicking, selecting 3D object, then selecting sphere. We're going to name this player. Okay, now once we've done that, we need to remove the sphere collider, so we can right click on the sphere collider component and select remove component. That's because the character controller that we're going to add to it has an inbuilt collider. So we'll add our character controller now, which we can do by selecting add component, then searching for character controller and selecting it. You can see it automatically adapts to the shape of the sphere. Okay, so now that we have the character controller added to our sphere, we'll grab the main camera and make it a child of the player. We then want to reset the main camera's position to the center of the sphere, so we can do that by manually entering 0, 0, 0. The next thing we need to do is add our mouse look script to our camera, so we can do that by dragging it from the project folder into the inspector with the main camera selected. Now if I hit play, you can see that the mouse look script is working as it should. So now we need to create a script for the player movement and add it to the player object. We can do this really quickly by selecting the player object, then selecting the add component menu before typing in the desired name of the script. We'll call this script free move controller. Then we select the new script option and it'll auto-complete the name of the script based on what we were searching for. And then we select create and add. We can now see the script has been added to the player object and created in our project folder. So now we'll open this script in Visual Studio by double-clicking it in the project window. With Visual Studio open, the first thing we're going to do is create a public float as a variable, which we'll call speed. I'll give this a default value of 5. This variable will control how quickly the player can move throughout the world. The next variable we're going to create will be a private vector3, which we will call input. This variable will be used to track the inputs that the player is pressing as numerical values. We will then need another private vector3, which we will call motion. This variable will be used to track the combined direction that we need to travel on a frame-by-frame basis. We now need to create one more private variable, which will be of type character controller. We will give this the name controller. This will store a reference to our character controller component attached to our player object. With our variables defined, we can then proceed to remove the start function. We will then replace this with the awake function. We'll inherit this from the monobehavior class by simply typing awake in Visual Studio, and IntelliSense should pick it up and we can press enter and it will auto-complete it for us. If IntelliSense hasn't worked out for you in this case, you can just type it out as it is displayed on the screen now. So in the awake function is typically where we'll make references to components that the script needs before those components get used in the execution of the script. So in the awake function is where we need to initialize our controller variable and make a reference to an existing component in the scene. We can do this by saying controller followed by a single equal sign. Then because this script will be attached to the same object as the component that we're trying to grab is, we can simply say get component followed by a set of chevron brackets. In here we put the type that we want to try and grab, so we're going to say character controller, and we follow that with an empty set of parentheses, and then a semicolon to end the line. And that's all we need to put in our awake function. With the awake function complete, we can move down to the update function. So the first thing we need to do in our update function is reset the value of our motion vector back to 0 so that it's ready to store a new set of calculations for the current frame. So we can do that by saying motion, followed by a single equal sign, and to simply reset it to 0, 0, 0, rather than having to write out the full vector like this. What we can do instead is much simpler. We can simply say vector3.0, which equates to the same thing. On the next line, we then want to detect and store the current inputs that are being pressed during this frame. Two of these inputs are defined by Unity by default, but one of them we will need to create ourselves. So to store these inputs in our input variable, we say input followed by a single equal sign, followed by new vector 3, and then a set of parentheses. Now inside the parentheses, we need to define three values, the x, y, and z values in that order. So let's go back to Unity and quickly discuss how each input axis correlates to a movement direction. When you select an object in Unity, you can see a gizmo with three directional arrows of three different colors. The up or green arrow is the y-axis, the forward or blue arrow is the z-axis, and the right or red arrow is the x-axis. The z-axis typically is used to move forwards and backwards. The x-axis is typically used to move left and right, and the y-axis is typically moved to use up and down. So the vertical and the horizontal axis are defined by default in Unity. The horizontal axis aligns with the A and D as well as the left and right keys on your keyboard. As the x-axis is responsible for strafing left and right, this is where we want to store our horizontal input. We do this by saying input.getAxis followed by a set of parentheses inside which we open a string and we write horizontal with a capital H. We then follow this set of parentheses with a comma, and next we have our y-axis. Remembering that the y-axis is responsible for moving up and down, we need to create a new input for that, and we'll call it depth. So we write the same thing, input.getAxis, followed by a set of parentheses inside which we define a string, and call this depth with a capital D. We then follow those parentheses with a comma, and the last axis is our z-axis, which aligns with our forward and backwards movement. So we'll say input.getAxis, followed by a set of parentheses, and use the predefined input vertical. On the next line, we will start calculating our motion. So first, we will calculate how far we need to move forwards or backwards. We do this by writing motion, and we add onto the existing value of motion by saying plus equals. We then need to get the direction relative to this object, so we access the transform of this object by saying transform with a little t, which we follow with a period. Then to get the forward direction, we can simply type forward, which returns it as a vector 3. We also want to make sure this is normalized, so we'll say follow forward with dot normalized. Now to multiply the magnitude of this vector, remembering that this is a vector 3, it's a direction, we want to multiply it by our vertical input to tell whether we're moving it or not. So we can simply say multiply with the asterisk, and then we say input.z to multiply it by our z input. Now we do the same thing here for our right direction movement. So we say motion plus equals, and we say transform, but we say right instead of forward, dot normalized, and instead of multiplying that by the z-axis of the input, we multiply it by the x-axis. Then on the next line, we'll calculate our motion up and down by saying motion plus equals, and rather than saying transform dot right, up and down like they don't change. Up and down up is always up and down is always down. So we'll say here vector 3 dot up, which will get the up direction in relation to the world. Then we'll just simply multiply that by input.y, which tracks our depth. Lastly, we need to apply this movement to our character controller, and we also want to multiply this motion by our movement speed. So we do this in one line by getting a reference to our controller, and then we access the move function from it. So we say controller.move, followed by a set of parentheses, and here we pass motion, and we multiply it by our speed. And now we want to make sure that it's relative to the frame by frame basis. So we say multiply that by time.delta time before closing the line. And that's the whole script done. So we'll save that and hit Control S. And now we can go back into Unity and set everything up. Okay, so now we're back in Unity. The first thing we need to do is set up our depth input so that, because the horizontal and the vertical ones are already set up. So what we do to open the project settings window is we find the edit menu at the top of Unity, and then we go down to project settings. which will bring up this window here. I just usually like to dock it right in here. So we then want to make sure we're on Input Manager here, and you'll see this axes property, which we can open. So you can see here's our horizontal input, which is already defined, and our vertical input, which is already defined. You can see they align with the keys defined here. So what we're going to do is we're going to create basically a duplicate version of one of these, and we'll call it depth. So we need to change this number up here to add a new one. So we say 19, and it'll add another one on the bottom here. So we'll call this depth with a capital D, like we refer to it in the script. And then what we need to do is define a positive and a negative button. It'll like copy the positive and negative from the buttons from the previous one. So we're going to change the positive button here, which will make it the number go from, or the related axes go from 0 to +1. So we're going to just call this space, which is our space bar. We can get rid of this joystick button 1 here. Then we have our negative button above it, and I want to make mine left control, so I'm going to call this left CTRL. So for the rest of these settings, we'll just copy the ones we see up here, and this is my vertical input down up here, so we'll copy the ones we see here. So we've got 3, 3, and then turn snap on. And that's our depth defined. So now we'll just go back to the inspector, and let's select the player and make sure everything's set up. We have our free move controller applied to our player object, which has a character controller component on it and has the main camera below it, with our mouse look script. So now we'll hit play, and you can see now if I press forward, my guy moves forward. If I press backwards, my guy moves backwards. If I press left, he moves left, and right, he moves right. Spacebar, he moves up, and left control, he moves down. And we can do combinations of these. Ooh. And that all works. So thanks for watching the tutorial. I hope you enjoyed it. Hope this helps you out. Please give me a like and a subscribe if you can, or leave me a comment or something like that. And we'll see you for the next one. Goodbye.